Hey everybody, in this video we're going to go over section 7.4, which is called graphs of sine and cosine. I'm going to go ahead and share my screen and we'll get started. All right, so this section we're going to be graphing sine and cosine. We're going to look at some characteristics of the graph of sine and cosine, and just know that where we get these values for our graphs of sine and cosine, the y values of the graph are going to come from our unit circle. So again, just recall that cosine, let me see if I can get my pen up here. Cosine is represented by the x coordinates here, and sine is represented by the y coordinates. So for example, sine of pi over 2 would be the sine of pi over 2, that would be the y value of pi over 2, so that would be 1. All right, so that's where those, the function values are going to come from whenever we start graphing these. All right, so we're going to start by just graphing sine and cosine. We're going to plot some points on the graph and then connect those points. So grab your calculator. You can also just refer back to the unit circle. So let me see if I can copy this unit circle over, and that way it'll save us a little bit of work on the calculator. Let me make this small. Okay. All right, so let's see. Sorry, I'm doing all this. I should have done this before. All right, there we go. All right, so sine of 0. Sine of 0, that's going to be the y value at 0. The y value at 0 is 0. Sine of pi over 4, that's the y value at pi over 4. So that would be square root of 2 over 2, which is approximately 0.707. Plug that in your calculator. Pi over 2, the y value at pi over 2 is 1. 3 pi over 4, the y value at 3 pi over 4 is, again, square root of 2 over 2, which is approximately 0.707. Sine of pi is 0. 5 pi over 4 is negative 0.707. 3 pi over 2, the y value is negative 1. 7 pi over 4, y value is negative square root of 2 over 2, so negative 0.707. And then back at 2 pi, that would be all the way around the circle. So back here would be y value of 0. All right, so go ahead and plot those points on the graph. All right, so 0, 0. So starting here at the origin. Then we have pi over 4. Pi over 4 is halfway to pi over 2. So halfway to pi over 2, that would be about here. And we're getting close to 1. We're about right here, 0.707. Pi over 2, we're up here at 1. All right, and then 3 pi over 4, that's halfway to between pi over 2 and pi. So that's about, let's see, about here. So there we're at 0.707 again, so about there. At pi, we're back here at 0. Then 5 pi over 4, that's about here. We're at negative 0.707, so almost to negative 1. And then 3 pi over 2, we're at negative 1. 7 pi over 4, that's halfway between 3 pi over 2 and 2 pi. So about here. And then at 2 pi, we're back at 0. Right, so you can see the graph emerge there. I'm going to try my best to draw a good graph here. So let me try to make this as big as possible. All right, and then I'm going to connect my dots here. I'll just use a highlighter, and that'll kind of be a little bit more forgiving. All right, so there's my graph of sine. Not perfect. Let me see if I can get it a little bit better. Okay. Still doesn't look very good, but I think you guys can see the general shape of the graph. Just a couple things I want to point out about the graph of sine. Notice how the graph of y equals sine of x. That's what we've graphed here. The graph starts at the origin and it increases. And a couple things I want to point out about the domain and range. So the domain, remember, that's the x values. So you would say, like, how far left does this go? How far right does this go? This graph is going to go on forever, so you could add little arrows to the end here. So the domain is negative infinity to infinity, whereas the range is only, it's going to oscillate, this graph oscillates between +1 and -1. So that's, that's as far up as it goes, that's as far down as it goes. So the range goes between -1 and 1. All right, so that'll come up again in section 7.6, so just wanted to point that out. Okay, graph of cosine, very similar. We're just going to use our unit circle. Let's see. We'll make this smaller, and then we will start writing down some function values. Okay, so I'm just going to put this here while I fill in my table. Y equals cosine of x this time. So cosine represents the x values or the x coordinates on my unit circle. So the x coordinate at 0 would be 1. Pi over 4 squared 2 over 2, that's 0.707. Pi over 2, x value is 0. 3 pi over 4, negative 0.707. At pi, my x value is -1. 5 pi over 4, x value is negative 0.707. 7 pi over 4, x value is square root of 2 over 2, which is 0.707 approximately. Oops, I'm sorry. I did the wrong one there. Let me erase that. I was jumping ahead too far. All right. So at 3 pi over 2, our x value is 0. 7 pi over 4, that's where it's 0.707. And then back here at 2 pi, my x value is 1. All right, so let's use that information to graph cosine. All right, so at 0, I'm going to plot the point 0, 1. So up here, notice how this one starts at 0, 1 instead of at the origin. 0.707 for pi over 4, that's halfway in between 0 and pi over 2. So that's about here. So right there. Pi over 2 is 0. 3 pi over 4, halfway in between pi over 2 and pi. That is negative 0.707, so almost to -1. And then pi is at -1. 5 pi over 4 would be negative 0.707, so about here. 3 pi over 2 is 0. 7 pi over 4, halfway in between 3 pi over 2 and 2 pi. So that's up here at 0.7. And then at 2 pi, we're up here at 1. Okay, so again, we could connect the dots here. I'm going to use a highlighter just so it's a little bit more forgiving. Maybe I can try to use this and it's not quite as thick. Okay, there we go. Woo. So far, so good. Yeah, that was pretty good. All right, so that's the graph of, just part of the graph of y equals cosine of x. All right, and then again, just wanted to point out the domain and range. The domain, again, is the x values. This is going to go on forever, so our domain is negative infinity to infinity. But our range, notice how our y values oscillate in between -1 and 1. So again, that is the range. So sine and cosine have the same domain and range. All right, so that's kind of nice because we only have, one thing to remember. You don't have a bunch of different stuff to remember for both of those graphs. Just know that they both have the same domain and range, that their domain is all real numbers, and that they both have a range of -1 to 1. Now, now that we've just seen what the graphs of sine and cosine look like, we can talk about what trig functions will look like in general. So you'll have something that looks like this. Y equals some trig function, or actually we're going to say A, that'll be our coefficient, times some trig function, maybe it's sine, maybe it's cosine, of bx minus c plus d. All right, so I'm using just letters in general right now because that's going to allow us to write formulas for the amplitude, the period, and the phase shift of these functions. All right, so again, in this scenario, trig is going to be represented by either sine or cosine. All right, so trig here represents either sine or cosine. All right, so amplitude. The amplitude of a function, the amplitude of a trigonometric function is going to represent the half the distance between the x-axis and the maximum value of the function. So it's half the distance between the x-axis and the maximum value of the function. So this is the formula for amplitude. We would say amplitude is equal to the absolute value of your coefficient A. Absolute value, because this is representing a distance, distance should always be positive. So the amplitude is sort of like the height of the function. All right, now the period, these functions are called periodic because they repeat themselves. So this is like represents one iteration of the cosine graph, and then you could use a stamp and continue to stamp across the x-axis, and this graph would continue to repeat itself. This is referred to as the period of cosine. This is the amount of time it takes for that graph to go through one full cycle. So the period of a function again represents the distance that it takes for this trig function to complete one full cycle. So the formula for the period is 2 pi over the absolute value of b. Now your book is just going to say 2 pi over b, but but really we should have absolute value of b in the denominator, because again this represents a distance. Distance should be positive. So it's 2 pi over the absolute value of b, where b comes from right here. It's this coefficient on x. Now the phase shift is just the horizontal shift for the function, so nothing fancy here. No, fancy or complicated description or definition. It's just the horizontal shift. They just call it a phase shift. And you find this by doing c over b. All right, so the phase shift is c over b, where again c is this number here and b is the coefficient on x. Okay. Notice that we didn't use d at all. D represents the vertical shift, but they will not be asking you to find the vertical shift here, so we're not using d at all. All right, so let's look at some examples and find the amplitude, the period, and the phase shift for these guys. All right, so maybe we'll make a little table over here. Number 1 says determine the amplitude, period, and phase shift for each of the following functions. All right, and I'm going to put some lines in here. Okay. All right, that'll keep us nice and neat. All right, so again, here's our formula, our general trig function, a times whatever the trig function is of bx minus c plus d. All right, so amplitude is absolute value of a. Period is 2 pi over the absolute value of b. And phase shift is c over b. All right, so you look at your trig function. Here we have y equals a times, here we're doing cosine of bx minus c plus d. And then you can identify what is a, what is b, what is c. All right, so you can see that in this example, a is 4, and then b would be just 1. And c is 0. All right, so if you put this in parentheses, we would have x minus 0. There's nothing being subtracted there. So c would be 0. All right, so amplitude, absolute value of A would just be 4. Period, 2 pi over B, that would be 2 pi over the absolute value of 1, which is just 2 pi. And then phase shift, C over B. We'll go ahead and plug in a number. C over B, that's 0 over 1, which is 0. All right, here, I don't really like the way this one's written, but your book will write them like this sometimes, or your homework will write them like this. So if I was you, if I saw this, I would go ahead and just switch the order and put that -3 at the end. That's going to make it more closely resemble our formula. So we would have y equals a times, in this case, sine of bx minus c, and then a plus d on the end. Now, don't let this part confuse you. This plus 3 on the end, this actually matches up with this vertical shift d. If you're just looking at what's being plugged into sine, it's just x. All right, so that 3 there, that -3, matches up with the vertical shift. So if you wanted to, you could rewrite this as something like 7 times sine of x and then -3 on the end. All right, so that kind of makes it more clear that x is the only thing being plugged into sine here. That -3, that's just on the end. All right, so amplitude is absolute value of A. A in this example, let me switch back to red. A is 7. Let's see, B is again 1. B is the coefficient on x, it's just 1. We don't have a C value here, so C is 0. So again, the amplitude absolute value of A would be 7. Period is 2 pi over absolute value of B, so that's 2 pi over absolute value of 1, still 2 pi. And then phase shift C over B, that's 0 over 1, once again, is 0. All right, and then our last one, y equals -1/2 cosine of x plus 7, so that would be A times cosine of bx minus c plus d. All right, so A in this case is -1/2. B, coefficient on x is 1. All right, and then we got to do a little bit of adjusting here. We're supposed to have a minus for our formula here, so we need to change this plus to a double negative, and that'll help us identify what C is. So you can see here, B matched with the coefficient on x, that was 1. X matches with x. This minus matches with this minus. So C matches with -7. All right, so let me just explain that one more time. Just wanted to make that a little bit neater. All right, so if we're looking at what we're plugging into cosine, bx minus c. All right, so 1 is the coefficient on x, so that matches with b. X matches with x. This minus right here matches with this minus right here, which means -7 matches with C. So C is -7. All right, so amplitude is absolute value of A. That would be absolute value of -1/2. Let me change back to red just to keep it consistent. Absolute value of -1/2, which would be just 1/2. All right, so the amplitude there would be 1/2. All right, so period is 2 pi over B. 2 pi over the absolute value of 1 is just 2 pi. And then phase shift, C over B. So C is -7, B is 1, so phase shift is -7. Excuse me. All right, let's do a few more examples. We have D and E here. Let's write our little table again. Amplitude, period, phase shift. And then put my lines in. Well, put that too high. There we go. Okay. All right, so looking at part D, y equals 2 times cosine of 3x. All right, so here is our formula y equals a times, in this case, it's cosine of bx minus c plus d. All right, so what is the amplitude? What's a? A would be 2, right? What is b? B is the coefficient on x, so that's 3. C is 0. All right, so now we can go in and find the amplitude. I was getting ahead of myself. Amplitude is absolute value of a, which is 2. Ugh. I hit a button on my pen. Let me try that again. All right, so amplitude is 2. Absolute value of 2 is 2. Period, 2 pi over absolute value of b. 2 pi over the absolute value of b. So 2 pi over absolute value of 3 is just 2 pi over 3. And then phase shift is c over b. So that's 0 over 3, which is 0. My cursor's going again. Very hard to see what I'm doing when my cursor disappears. All right, and then our last one here, 4y equals negative 2 times sine of 7x plus 6 pi. We need to get y by itself, so you have to start by dividing by 4. Now, in this case, you're not dividing each individual piece by 4. You're dividing this whole thing by 4. So divide this whole thing by 4, and that's going to adjust your coefficient out front. So let's see. I can figure out where my cursor is. Okay. Y equals negative 2 over 4, that reduces to 1/2, times sine of 7x plus 6 pi. All right, so I'm going to write the general formula for a general trig function under here. Y equals a times, in this case, sine of bx minus c plus d. And then we can identify what is a. In this case, let's see, try it one more time and see if I can get my cursor to pop up. A is absolute, let's see, a is negative 1/2. So absolute value of a would be just positive 1/2. And here we can see b is coefficient on x, that's 7. And then c is, let's see, we got to change that positive to a double negative. So change that plus right there to a double negative. And then we can match up and say, okay, well, b matches with the coefficient on x. So b is 7, x matches with x, minus matches with this minus. So c matches with negative 6 pi. All right, so let's go over here and find the period and the phase shift. Period is 2 pi over the absolute value of b. So that's 2 pi over absolute value of 7, which is 2 pi over 7. Phase shift is c over b. So that's negative 6 pi. Sorry. Negative, let me find my cursor again. Negative 6 pi over 7. All right, so phase shift is allowed to be negative. Amplitude and period should not be negative. All right. If you have any questions, please let me know. I know I went through this kind of fast, but we've done this, you know, approach of changing the positive to a double negative a few times already, so you should be somewhat familiar with that. And then you've also done work with graph transformations in chapter 4, so you should be somewhat familiar with, you know, identifying things like, you know, A, B, and C in this case. So like I said, let me know if you have any questions. Otherwise, I'll see you guys in the next video. Hope you have a good day.